over here. We're going on, excuse me, 4.2 today, specifically graphing lines. Yep. Keep an eye out for folks to join. Yesterday was, get used to the, basics of the coordinate system, X, Y axes, and plotting points, ordered pairs, X, Y pairs. Today specifically, 4.2 section is taking that step to plot some points from an equation and then connecting the dots, basically to graph the line. We might, any luck, will actually move right into 4.3 also, which is graphing using the intercepts. And we've actually kind of been doing that, which I will show you again, relate one thing to another. All right. So just a couple things to talk about. I mentioned sort of conventions. I probably should say that's kind of like my convention, that I'm willing to say every one of these squares, every one of these lines represents one unit. Now, if you're actually working with a graph, creating a graph yourself for some situation, it's expected that you provide at least a basic unit somewhere on that axis, so we know how big each line is, or each square on the grid. If you tell me one thing, I can count the rest, right? Similarly, just labeling your axes. What does this axis, what numbers go on that axis? What's the concept that that axis is counting? Well, abstractly, it's X and Y, but we'll see, for instance, in some situation, maybe time is this horizontal axis, so over a period of time, hours, days, whatever. And the vertical axis could be any resulting output, distance or cost or something like that. So, some letter, some indication as to what the axis represents is usually expected. More formal situations, even you maybe have part of this graph and you put a label out there on the side. Some other classes, if they ask you to make a graph, they want you to label the axes that way. Okay, well, graphing our equations. So I'll set myself up here for a couple of these. All right. Even on some of your homework already in Mom, I noticed different size units on the axes. That's just another good point to make. The size of the unit doesn't have to be the same on each axis, right? This might be 1 day, 2 day, 3 day, 4 day, and this is, $100, $200, $300. As long as it's consistent within the axis, you can't suddenly start with 1 and then go to 5 and then to 20 or something like that. It's got to be the same size step. Hopefully that's kind of obvious, but just making sure. Okay, we're going to use that method of building a table to come up with points and plot those points, and hopefully we do it correctly, and then we can connect those dots and they should form a line. So the first one I'll start with over here. See if I can give myself room so I can maybe work back and forth. Yeah, you can see me. Let's just say this one, right? Y equals 3x minus 1. A linear equation, 2 variables. It's in one of those 2 basic shapes that I mentioned yesterday. And so we want to find 3 solutions. That's what we're doing. We're finding pairs, ordered pairs. Let somebody in here. Finding 3 ordered pairs that make it true, and then we can plot those points, connect the dots. So, I'm doing this kind of thing, a T-chart. One column is my X values, the other column is the Y value. Come on, frog. In this shape, it's usually easiest to just pick some nice, easy X values to plug in, and then you do the calculation and come up with the Y value. I like to just, usually, like I say, pick some positives, a negative. I'm just jumping around here, picking any old numbers, really. And then I'm going to put them in for the x and see what I get for y. So here, if x is a -2, right, I get 3 times -2 minus 1. So it's a -6 minus another is a -7. I'm running into my graph. So there's one ordered pair. I've kind of used up that space, so I'm going to write that ordered pair down here. Okay. If I plug a 0 in, if x happens to be 0, right, I'm on this y-axis someplace, that's going to be an intercept. If x is 0, 3 times 0 minus 1, that's just -1. If x is 0, y has to be -1 to make that equation true. You guys seeing that okay? Yeah, let me know, speak up if I can see it's a little blurry. I should make my lines bigger on my graph, my template someday here. If x is 2, right, putting a 2 in for the x, 3 times 2 minus 1, 6 minus 1 gets me 5. Right, if x was a 2, the y value that comes out is a 5. Okay, there's 3 solutions. I could pick a bunch of them if I wanted to, but now I'm going to try to get those points on this graph and not have it look too messy. If x is -2, right, going backwards, the y is -7. So counting down, 1, 2, 3, 4, 5, 6, 7. -2, whoops, I lost it. 3, 4, 5, 6, 7. There it is. Yeah, looks pretty good. Hopefully you're following this and can count on your own squares on your graph paper, make it look good. All right, so there's one of those points. If x is 0, the y value goes with it as -1. X is 0, I get a -1. So xy, 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 right? 3 different distinct points. If x is a 2, the y value was up to 5. 1, 2, 3, 4, 5. And that -7 over there, that went with this answer up here, right? All right, so there's those 3 points on my graph. And find my big ruler here. And not too bad. I don't have the total graph paper grid here, but close enough. Connect those dots. Okay, so there now is a graph of all the solutions. I like to put my little arrows on there, like I mentioned yesterday. It goes on and on forever. Every possible point you can imagine coming up with, every combination of that x value with that y value is a solution. You know, it looks like, you know, almost like 1/2 0 or something like that. But this is a picture of all the solutions. Plot those 3 points. Get them on your graph there for you. I'm going to try this today here. See what happens. Okay. Oops. There it goes. How about y equals -2x and just +4. Okay. -2x + 4 came through on your TV, your graph, your screen. Let's see, I'm going to pick some numbers for you and then ask you to do this, okay? I'll wait for you. How about just, can you plug in -1, 0, and 1? I think mom actually kind of starts out this way in 4.2 in particular. It gives you that table, and then there's these little boxes over here where you're supposed to do what we just did. I just did. Find the y value and plug it into the box, and then you can put it on the graph. All right. I chose these numbers here so that we would all be doing the same 3 calculations. And let's let Danny in here. So put those 3 values in one at a time and come up with the corresponding y. And then we'll put them on the graph. I'll get rid of that junk here. You might notice I just work with that stuff on the right side, almost like turn it around. So I get -2 times -1 plus 4. And then whatever that turns out to be, that's the y value on the other side, right? I'm just going to do one here. Hopefully you're on the right track there. Excuse me. You want to start recognizing or understanding that if you're putting a 0 in for one of the variables, you are talking about being on one of the axes. You're finding one of the intercept points. That specifically is what 4.3 tries to get us to do, using intercepts to graph. Because plugging zeros in are usually kind of easy. So if x is 0, that means I'm up or down on the y-axis. Say this over and over. Whatever 0, the other one is the intercept that you're on. So x is 0, huh? -2 times 0 plus 4 is just going to be a 4. 0, 4 is my y-intercept. If I am going too fast, slow me down here. I put in +1. -2 times 1, I get -2 plus 4, it's only a 2. All right, so I could just put parentheses around those, but probably good to just point out, if a problem asks for the ordered pair, you need the parentheses and you need the comma, okay? You need to write it all the way out like this if it asks for an ordered pair. Otherwise, mom will ding you, call it wrong or something. If it was a test, I'd probably give you some partial credit, but I know we look at things so quickly and we try to, I know what we're supposed to do, and we don't read carefully and miss details. That's unfortunate, read carefully. All right, so hopefully those 3 points are good for you. 3 solutions. I just keep, emphasizing that's what we're doing, finding solutions to that equation. -1 up to 6. 1, 2, 3, 4, 5, 6. Over to -1. First point. 0, 4 on the axis. 1, 2, 3, 4. X is 1, Y is a 2 up here. 3 points fairly close together. So got those 3 dots. If you did it correctly, they should pretty clearly look like they're on the same line. Connect the dots. They don't have to be, it doesn't have to be a real huge line. Connect the dots and put the arrows on it. Any issues there? Anybody? Jump in and let me know, okay? Couple things, qualities of these graphs we want to start recognizing. 4.4 is all going to be about the slope. Is the line going uphill, left to right, right? Uphill, or is it going downhill? What is the slope? We're going to actually have a value, a number in our equation that tells us how steep that line is. And, well, I'll just get to it and just start thinking about it. That number that tells us what to, oh boy, what to multiply the x by. That's, how fast does this grow? If I put something in, I'm going to immediately multiply it by 3. So my y value is 3 times my x, and then I'll take away 1. But that positive number tells us my line has a positive slope. It should look like it's going uphill. This one has a negative number. So it's going to go downhill, negative slope. That value that's multiplying the x is going to be our slope number. That's 4.4. All right, let's do it again, okay? All right, got some crud in there. So now I'm kind of going through all these little different variations of equations. Kind of, we'll do both versions, both forms, but just kind of a variety of looks, you might say. Here's one. Often we start and say, this is the simplest, right? This is the simplest linear equation. There's nothing modifying or multiplying dx, and there's no extra plus or minus. Almost just talk this one through. Whatever I put in for x is going to be exactly the same for y. Y is equal to the x value. 1 gives me 1, 2 gives me 2, 0 gives me 0, -1 gives me -1. That line is that one that kind of looks like a 45-degree angle, diagonal. So that's what that version looks like. So if I get 1, remember I talked about that 3 in the previous problem or two ago. Here's a similar shape, right? I'm just going to put a value in for x and then multiply by 3, and that'll be my y. This one doesn't have any additional plus or minus on it. Right? I'm not going to do anything after I multiply. So again, I can just pick some numbers, any numbers you want that look like, easy to calculate. Can we do this in our heads, right? If I put in -2, 3 times -2, I get -6. If I put in 0, I still get 0. And if I put in 2, I get +6. That was like a +1 being that number there. So positive uphill, +3, positive uphill. -2 gives me -6. 1, 2, 3, 4, 5, whoops, 2, 4, 6, come on. And 0, 0, 2 up to 6, 2, 4. Can't read my lines today. All right, so there were those 3 points. And hopefully you can see if I was careful with my ruler, I could connect those dots, not too bad. Notice, because there's no extra plus or minus value, right? Those lines, if I put in a 0 for x, I'm always going to get a 0 for y. Even here, if I put in a 0 for x, 3 times 0 is still 0 for y. So this shape equation, you might call it simple shape, always goes right through the origin. That's the intercept for both axes, huh? All right, here it goes. What did I do for myself here? Y equals 1/3 x minus 1. Okay, I briefly mentioned, gee, how do we deal with this one to make it easy on us yesterday? You can put any number you want in there, and you're just going to have to multiply by 1/3. Shouldn't really be any issue, but can we choose a number that makes it work out nice? Well, any multiple of 3 that I put in for x is going to result in a whole number or an integer value. So something like, -3. 0 is still a multiple. It's 0 times 3. I'll jump up to 6 just to be different, huh? These are multiples of 3. So when I multiply by 1/3, it sort of cancels out and I'll get a whole number. So if I put in negative, all right. Loosening up some crud, I'm sorry. 1/3 times -3 minus 1. I put in the -3, right? 1/3 times -3 is -1. All right, you can figure that one out. Or you can think of this as -3 over 1. So it looks like fraction times fraction. -1 minus another one, so -2. If I put in 0, 1/3 times 0 is still the 0 minus 1. I'm just going to get -1. -3 went with -2. 0 went with -1. And one more if I put in a 6. Right, putting the 6 in for x. 1/3 times 6. I'll make it look like a fraction. One third times 6 is 2, right? You're canceling if you want. 2 and then minus 1 gets me 1. So 6 went to 1. Now we're all such experts at multiplying and solving those equations. So I did that. little quicker than maybe you would, or than certainly we did when we started last chapter. If that's okay, I've got those 3 ordered pairs now. I'm going to get my calculations out of the way here, all right? And putting those on the graph, -3 was -2. And 0 got me -1. 6. X value of 6 all the way up to what? 1, 2, 3, 4, 5, 6 up at 1. And those 3 dots. And yep, connect the dots. I do get a nice line. Just talking qualities again, kind of priming us for what's coming ahead. That number I said that's on the X is going to tell us the slope, how steep this graph is, and specifically, is it a positive slope for a positive number or a negative slope for a negative number? Notice this is a fraction, less than 1, right? A small slope. Notice how kind of shallow that one is. All right. How about that one? You read that? Yeah, I've got -1/4 x plus 2. Sorry, folks, got something going on here. Picking some numbers now to plug in for the x value. Again, still it's that same shape, just happen to have a fraction to deal with. Easiest to pick some value for x that we can multiply and get a decent number for. Here I have a denominator of 4, so picking multiples of 4 work pretty well. I'm in -4, 0 still works, and how about +4? I put in -4, I have -1/4 times -4 plus 2. Watch out for that negative and the negative, right? Don't lose your negative signs.
I have a quick question.
Okay.
So when you're picking out the X's, are you really just picking them out of nowhere, or do you have a reason you're picking those numbers?
In the big picture, I'm picking them out of nowhere. I get to choose whichever ones I want. Because really kind of any number for x I can put in here and then it will simplify to figure out what the y is. Now, because these had fractions, I'm being a little more specific. I'm picking a number that works well with the fraction. A number that is a multiple of the denominator will always simplify to a whole number or an integer value, right? We'll get rid of the fraction. So here, on this one, I had chosen, multiples of 3, like -3. 0 still always works. 6 was a multiple of 3. So when I put the 6 in, I got a 2, right? Here, I chose multiples of 4, -4, +4, and again, still 0 works. So
Okay, that makes sense.
a little bit of thinking to help, make nice numbers out of it.
Is there going to be any point where we're going to have to pick out just random X's on
Well, I think you'll see, I think we're talking about section 4.2. I do believe that they start out by telling you which numbers to use.
Okay.
And then eventually, as you work through those problems, they'll say, find 3 solutions and plot them. And so you have to pick the numbers yourself.
Okay. Thank you.
Yeah. In general, you can pick any number. Might as well try to think of one that looks like that'll be pretty easy, right? So I put the 0 in, -1/4 times 0 plus 2 is just a 2. I didn't finish the first one, did I? Negative times negative is 1 plus 2 is a 3, huh? Did I do that right? -4, right. -1/4 times -4, negative times negative is positive. The 4's cancel and makes it a 1. 1 plus 2 is a 3. So when it's -4, I got a 3. Make that look a little better. And the second one I just did when it was a 0, when x was 0, turned out to be a 2. Finally, if I put in a positive 4, -1/4 times 4 plus 2, you know, if you like, right, I go back and forth for you mainly. If you like multiplying this fraction by something that looks like a fraction, well, make your 4 look like a fraction. I wrote it as 4/1. Don't have to. But that's now negative times positive is -1 plus 2 is a 1. So there's 3 points. -4 is up at 3. I'm going to erase my work again, if that's okay. -4, 1, 2, 3, 4 for the x. Make sure you know you're on the right axis. Oh yeah, that's the x value. Up at 3, right? 1, 2, 3. I say things like that because I've seen those kinds of unfortunate mistakes, and well, every time he says one of those things, it's really important. 4, all the way at 1. 1, 2, 3, 4, up at 1. Yeah. So even from your screen, that should look pretty much like a line, huh? Negative number there means that we expect it to go downhill, and it's a fraction less than 1, so yeah, it's a kind of shallow slope. Let's see, I'm going to do one more just to point out. Let's make it. My fraction versions were 1 over something. It doesn't have to be 1 over something. Here's 2/5 for a fraction. I still want to pick some numbers that work nicely with the 5. Just remember whatever it simplifies to, I guess, I still multiply by the 2 that's on top. I still usually use a 0. Just kind of a nice preference. My preference is see what that graph's doing over the full area here. So I usually pick a negative number. You don't have to. So if I pick some 5s, it should work out to give me some nice number answers. All right, so here I would do 2/5 times the -5, and I'll put that over 1, minus 3. Yeah, a little too small, messy. 2/5 times -5. Now the 5s are going to go away and leave a -1. And now I have 2 times -1 for that multiplication, right? -2 minus 3 more, -5. Oh, that's just a coincidence. -5, -5. Zero's always nice in this. I put in a 0. I'm just going to get -3. And if I put in 5, again, the 5s here would cancel, but I'm left with the 2. 2 minus 3, a -1. Hoping those calculations are ones that you're comfortable with these days. All right. So just putting them on the graph, -5, -5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Just about there. 0 for x, negative 3 for y, 5 for x, negative 1 for y. 1, 2, 3, 4, 5, negative 1. Again, it's still less than 1, but it's positive, so it's going to be a kind of a shallow slope. I missed. I didn't get my ruler out. Okay. There it goes. All right, how about a couple in that other shape? All right. The x's and the y's. There's a couple ways you can go about doing this. One is to just, deal with the shape and pick some numbers. We're still going to try to pick some numbers here to plug in for x and y.
I think that's where I'm still having my trouble, is figuring out what numbers to plug in when it doesn't give you like something in the equal sign. I guess that will just take practice.
I can pick any number. Pick any number you want. See, if this one doesn't have a fraction, so that means I don't even really have to think about it too much. I can pick any nice whole number and it'll work out to give me a nice whole number value for y. So I usually just kind of pick.
Yeah, see, I feel really comfortable when it's like that, but I think when we mix in fractions, I think that wall goes up and like I get scared all over again of the fractions. Well, just because fractions are scary. So when we're mixing them into something like this, I think it gets a little bit more intimidating.
Yes, well, what makes the fractions easier to work with is picking a number that is a multiple of the denominator. Okay, pick a number that's.
I'll keep that in mind.
Yeah, because then if you're carefully multiply that fraction times that multiple will always sort of cancel out and reduce to a whole number, and you won't get a fraction answer. That's kind of the only thing we're trying to avoid, is getting a fraction answer. There's no real reason other than we kind of like to avoid the fractions.
Yeah, I'm going to really have to keep in mind to find something that works with the denominator.
Yeah, okay. So this one here, this is kind of what we were doing, what I suggested yesterday, and specifically what 4.3 is asking you to do is plug in the zeros for each of those two variables. All right, those are often good choices, and I'm gonna just pick one other number and see what happens. Also, and I might get a fraction. Okay, when it's in this shape and you leave it in that shape, means we could move it. I'll do that in a minute. You just have a greater potential to run into a fraction answer for your other value. But if I start like this, I'm going to use a 0 for the x and see what I get for y. And then I'm going to use a 0 for y and see what I get for x. Because that always kind of makes one piece go away, right? But one's a 0. If I put in a 0 for x, so this is just like, call it educated guesses, is what to put in here. I know, it's like, oh great, we're not that educated yet. He's making choices he knows.
Is this starting, are we starting to move into 4.3 now?
Not specifically, but this is really, is what you're going to be asked to do in 4.3 is graph using the intercepts. And most all of those equations are going to look like this shape. And here's where I was saying, they're going to give you mostly nice problems where, notice here, well, that's just a 1y. If this is going to go away, that means y equals 4, right? It's going to work out nicely. They're going to give you nice numbers. If you use the zeros, you're going to get nice answers. You could say this is 4.3. This is what you're going to do in 4.3, at least to start. We want to think about it a little more in terms of what do the intercepts mean when we get there, all right? Here we're doing the calculations, but these are the calculations you will do at 4.3. If I put in a 0 for y now, I get 2x plus 0 is 4. So that goes away. I get 2x equals 4. Divide by 2. See that 4 is divisible by 2. That's kind of what I was saying. The problems you're going to run into always kind of work out nicely. No reason they really should, other than the program's giving you nice numbers to practice with. Is that okay? I got the x equals 2. Now make sure you get those in the right position, right? That was the y value, and so I just found my x. So there's two ordered pairs. They will, because they have the 0 in them, they will be the intercepts. I'm going to do one more just to say, well, sometimes it gets messy. Say, what if I were to choose a 3 for the x? What happens here? 2 times 3 plus y equals 4. Oh, this is not even going to give me a fraction, right? 6 plus y is 4. Subtract the 6 and I get -2. 3, -2. A little messy there. 0, 4, 2, 0, 3, yeah, better keep going. 3, -2, 3, -2. Yeah, I did okay. They're on the same line. Yeah. I'll make one that works out messier. Okay. There's another one of these. I'm still going to use some zeros, okay? But this one I know I'm going to get fractions with, all right? Notice the 2 divides into the 8, which means if I put a 0 for y, I'm going to get a nice number for x. But the 5 doesn't divide into the 8 evenly. So if I put in a 0 for x, I'm going to get a fraction. I'm just showing it can happen. Just want to be careful with your calculation. It makes it harder to graph when we have fractions because we have to kind of estimate its position. So I'm still going to do this, and these will still be the intercepts. If I put in 0, the intercept might just be a fraction number. And just arbitrarily, I'm going to say I'm going to put in a 1 also, 3 points. The mom problems usually ask you to calculate 3 points. It's like 2 of them should be good enough, but the third one sort of confirms that you've got all 3 of them correct and they're on the same line. If x is a 0, right? If x is 0, I get 0 plus 5y is 8. Divide by the 5 and get 8/5. 8/5. So they're already, right? 0x is 8/5 or 1 2/3 if you're in your own head. 1 3/5, but 1 3/5 when I try to put it on the graph. If I put in a 0 for the y, oh, that one will turn out not too bad. 2x plus 0 for y means that whole thing is a 0. They're okay with that. I just, 5 times 0 is still just going to be 0. 2x is 8. So divide by the 2, I got x is 4. So 4 was the x when y was a 0. That one will look okay on the graph. And one more. I have no idea what's going to happen if I put in a 1 for the x. 2 times 1 plus 5y equals 8. So that's 2 plus 5y equals 8. Taking of 2, so subtract the 2. 5y equals 6. And divide by the 5, and I'm going to get y equals 6/5. Kind of went all around too much there. Is everybody okay with my calculations there? Now, if I'm real careful, I can sort of estimate those fraction positions and still should look like a line. When it's a 1, it was at 6/5, 1 1/5. 1 for x and 1 and a little more for y, huh? sort of estimating where that is. When it was a 0 for x, it was 8/5. Here's where one of the few times you might turn it to a mixed number in your own head, right? 1 3/5. 1 3/5. And when x was a 4, it was finally all the way out at 0. 1, 2, 3, 4. Yeah, I didn't do that too badly. At least estimating the position of those fractions, I got them pretty close to the same line. So it's kind of a cheat in a sense that the problems that you will see mostly in this shape do have numbers here that will divide evenly into that one, which makes the zeros work out real nice to give you whole number answers. If you need to calculate a third value, you just need to pick some other number. I would keep it small to make it easy to, not too big and messy. Keep it a small number and then just be real careful and come up with your fraction answer.
So we need to be converting these fractions into mixed numbers in order to plot them on the graph?
Well, it's kind of up to you. How would you graph 8/5?
Well, I'm just trying to learn and figure it out. I have no idea.
Oh, well, okay. So if I was, 8/5? Yes, that's an improper fraction. I hate to say you have to, right? Oh, there's somebody who must have fell out and then had once back in. How do I want to graph that? I mean, really, if you threw it in your calculator, you'd get 1.6. If you want to turn it into a mixed number, you're comfortable enough with that process. That's 5/5 and 3/5, right? 1 3/5. So finding an estimated position for an improper fraction, yes, you kind of have to choose one way or another, I would say, to turn it into a decimal or turn it into a mixed number. One of the few places where a mixed number comes in handy for us in this class. I hope that's probably not the answer you want, but I hope that makes sense. The big picture here is we have an equation and we're trying to graph the line. And so we're finding solutions, but we're picking numbers to put into the equation for one value and then doing the simplification to find the other number, trying to come up with X, Y ordered pairs for each equation. And the more familiar you get with them, maybe is a nice way to say it, the easier it becomes to pick numbers that you recognize will not be too messy, work out nicely. A couple weird ones here that we run into, I'm running out of time but that's okay. A couple unusual ones, all right, that have sort of a special shape. How about one that just says y equals 3? There's no x value there. This is a special certain kind of line, and you have to learn what kind of line this is and keep it separate from the next one we're going to do. Try to think about what it's saying. Y is always 3 and doesn't care what the x is. Y is always 3. Even if x is some number out here, it doesn't affect this equation. Y is always 3. Y is always 3. Horizontal line. We could say y is 0x plus 3. 0 times x. Now, if I think about that 0 in section 4.4, we're talking about how steep is that line if it's 0x? How steep is that line? It's flat. There's no slope or slant. That's what the 0 implies. Horizontal line shape, okay? No x's. No x's. Right? There's no x's there. It's just whatever y is. Here's the other one. There's no y's. X is always -2. You want to be able to step back and look at that and say, okay, which one is this? Oh, X is always -2. No matter, there's no y in there to change it. X is always -2. Mom doesn't like it when you put in too many dots. I think it usually wants 2 dots and then be done. I remember seeing people getting things wrong and I had to go fix it for them if they tried to put in a bunch of dots like I just did. Maybe updated mom is better at that. But hopefully this makes sense. X is always 2. Yeah, that's supposed to look like a vertical line. There's no y's in there. Y doesn't change anything, affect this one. All right. Now this one has an x-intercept of -2, right? But this one will never cross the y-axis, right? It's parallel to that vertical y-axis. Conversely, this one has a y-intercept of 3, but it will never cross the x-axis, parallel to that x-axis, like that. Now, yeah, just the last comparison. Notice that's different than this one, which I think I did that one earlier. That one has an X. It's still a pretty simple shape. And if I did all that table stuff, remember I just put in any X value and I'm just going to multiply it by 3. And that was the one, remember I said, oh, those always go through, if I put in 0, I still get 0. Always go through the origin. And that has a steepness or a slope of 3. And 1 gives me 3. That one does depend on what X value I put in, right? This one has X's. That one has no X's. There's sort of no corresponding difficulty from this one. This one is really, when we talk about slope, we'll see this one has to just sort of be a standalone shape. We can't relate it to something with a y in it. It's just X is always -2. Okay. So those couple unusual or special cases that you kind of have to memorize. You want to memorize that shape. So for instance, I saw a mom problem. If you can see that asks, what's the equation of that line? I think it's near the end of 4.2. What's the equation of that line? Oh, that's one of those special ones. It's horizontal. It's always at that same y level. The y is the same all the way through. Well, what is that y value? I made it a -1. So for that, going the other way around. Here we got the equation, graph it. If they give you the graph, we will have to be able to write the equation. Oh, that one's a special one we just talked about, so it always goes through -1. I could do something similar out here and say, what's the equation of that line? Got it hard to see my squares on the screen. I think that's 1, 2, 3, 4, 5. It's always going through an x value of 5. No matter what the y value is, x is always 5. Okay. All right, folks, that wraps it up today. We got through 4.2 very well, all the way through all the different ideas there. 4.3, we've touched on so much of it that'll, we'll definitely do 4.3 and start 4.4 tomorrow, talk about the details of how steep is that line? What is the slope of that line? So that'll be tomorrow. Okay.
Thank you so much.
You're welcome. I'll get to those hand-in homeworks pretty soon. You got them turned in yesterday, or some of it you did. Oh, I have to just say, I see that some of you guys chat, and maybe you're chatting with each other. I hope if you really need to ask me a question in the middle, that you just speak up. But I I see most of you talking to each other in the chat. That's great. But if you need to send me a question, send me a question. We'll keep practicing. Like I see here somebody saying, I still have trouble with the fractions. So maybe we'll just need to, go back and refresh, changing to a mixed number a little or something like that. Don't want it to be a big deal for you. All right, folks, have a good day. I'll see you tomorrow. Okay.
You have a great day. Take care.